Hello everyone. Welcome to the solution of LeetCode problem 198 named House Robber. In this problem, the statement is, suppose you are a potential robber planning to do rob in the houses along a street, and each of the house has some amount of money. The only constraint is, if I rob in a particular house, I cannot rob any house adjacent to it. And if I do so, then the alarm will automatically ring and it will call the police. So in this problem, we are given an integer array representing the amount of money of each of the house, and we have to return the maximum amount of money you can rob without alerting the police or without robbing to the adjacent houses. I hope you understood the statement. Now let's move on to the example 1. In the example 1, the input array consists of 4 elements, which is 1, 2, 3, and 1. And the output is 4. It is why? Because if I rob the first house, and we cannot rob into the second house because it is adjacent. So if we rob the first house, we can easily rob the third house. So the amount is 1 plus 3. 1 is stored in the first house and 3 is stored in the third house. So the summation is 4. So in this case, we have to return 4. In the second example, the input array consists of 5 numbers, which is 2, 7, 9, 3, and 1. And if we rob the first house, we will get the amount of 2. After that, we cannot rob the second house because it is adjacent. Then we can rob to the third house, which amounts is 9. So total is 2 plus 9, which is 11. After that, we cannot rob the fourth house. And finally, we can rob the fifth house, which has amount of 1. So the total amount is 2 plus 9 plus 1, which is 12. And the constraint are, the input array length can be in between 1 to 100. And each of the array element can be in between 0 to 400. I hope you understood the problem statement, example, and the constraint. Now let's move on to the intuitive approach to solve this problem. Now, to solve this problem, we have taken the first example. In the first example, the input consists of 4 elements, which is 1, 2, 3, and 1. Now, the constraint is, suppose we have taken the first element, and as we taken the first element, so we cannot take the second element, which is 2, because it is adjacent. After that, we can take the third element. As we take the third element, we cannot take the next element, which is 1, because it is adjacent. So in this case, the total summation is 1 plus 3, which is 4. Now, the main problem is, how can we solve this problem? We have seen that for each of the element, we have 2 choices. Either I can take it or I cannot take it. So the basic intuition is, if in any of the problem, for each element, either we have choice, we can have 2 choice, 3 choice, or multiple choice. In most of the cases, this kind of problem can be solved using dynamic programming. So the basic criteria to understand a problem is in the dynamic programming category is that we have to determine the sub-problem and the base cases. If we understand the sub-problem and the base cases, then it will be easy for us to solve a problem by using dynamic programming or DP. Now let's understand, or let's explore the sub-problem of this problem. At first, we are at the first element, which is 1. For the element 1, we have 2 choices. Either I can take it or I cannot take it. If I take it, the temporary array will contains the value only 1. And as I take 1, we cannot take 2. So our next element to explore is 3. So here we will explore 3 after taking 1. And if we cannot take element 1, then we can simply explore the next element, which is 2. And our temporary vector will be empty as we are not taking anything till now. Now, for this element 3, we also have two choices. Either I can take it or I can ignore it. If I take it, the temporary vector will contain element 1 and 3. And if I take 3, then we cannot explore element 1 because it is adjacent. So here the iteration is over. Now there is another possibility. We can simply ignore 3. If we ignore 3, then we can explore this last element, which is 1, and our temporary vector will contain the element 1, which is the first one, this one. Now, for this last element 1, we have again two choices. Either I can take it or I can ignore it. If I take it, then our temporary vector will contain the value 1 and 1. After that, the iteration will be over. And there is also one possibility. We can simply ignore it. So here, if I ignore the element 1, our temporary vector will contain only the value 1. And the iteration will over. Now for the element 2, we have two choices. Either I can take 2 or I can ignore 2. If I take 2, the temporary vector will contain the element 2. And if I take 2, we cannot take element 3 because 3 is adjacent to 2. So for this, we have to consider the last one. Now we have to consider the last one. Or we have another choice. We can simply ignore 2. If we ignore 2, the temporary vector will remain empty. And if we ignore 2, we can explore the third element, which is, for clearing purpose, I have removed the previous footmarks. Now, for this last element 1, we have also two choices. Either I can take it or I can ignore it. And if I take it, the temporary vector will remain 2 and 1. And our iteration is over here. And if I ignore it, our temporary vector will contains only the value 2. And our iteration is over here also. Now for this element 3, if I take the element 3, then our temporary vector will contain the value 3. And if I take 3, then we cannot take 1 because it is adjacent. So here the iteration is over. And we can also ignore 3. So if I ignore 3, we can take element 1, or we can consider the element 1, but still we cannot take anything yet in this path. So the temporary vector will remain empty. Now, for this last element 1, we have two choices. Either I can take it or I can ignore it. If I take 1, then our temporary vector will contain the value 1 and our iteration will be over. And if I ignore the element 1, then our temporary vector will remain empty. Now, this is the decision tree of this dynamic programming problem. Now let's see. In this problem, we have seen that this decision tree where the root is 1 and this decision tree where the root is 1, both of the tree are similar. So we can say that this is one of the repeating subproblem. Or in both of the tree, we have to determine whether, or in both of the tree, we have to explore the decision tree where the root is 1. Now, there is also another overlapping subtree, which is this, where the root is 3, which is this, where the root is 3. So we can say that this problem has overlapping subproblem. So we can say that this problem basically belongs to the dynamic programming problem. Now I hope you understood this decision tree. Now let's erase it. Now, as this is a dynamic programming problem, we will solve this problem by using a DP array. Now at first, we are taking a DP array of size 4. Suppose the name of this input array is A and the name of this new array is DP. Now, suppose our input array only has the element 1, which is the first element 1. For this case, we will always take the first element 1. So our first element of the DP array is 1. Now for the second element, if currently our input array consists of 2 elements, now either I can take the first element or I can take the second element. So here the DP of second element will be maximum of 1 and 2, which is 2. This is the first index, this is the second index, this is the third index, and this is the fourth index. Now, for this third element, we have two choices. Either I can take it or I can ignore it. Suppose if I take the third element, then our result will be maximum of 3 plus dp of I minus 2, which is 1, comma, or I can simply ignore the third element. So in this case, we can only take the element 2, which is this. So here maximum of 4 and 2 is 4. So here the answer will be 4 for this third element in this DP. Because we can take this 1 and this 3. So here the summation of 1 and 3 is 4. Now for this last element 1, we have also two choices. Either I can take it or I can ignore it. If I take 1, then the DP of 4 will be maximum of this 1 plus DP of I minus 2, which is this, or I can simply not take the last element. For this, the DP of I minus 1 is 4. So here the maximum of 3 and 4 will be 4. So finally, we have seen that for the last element of this DP array is 4, which is the expected answer of this problem. So finally, we can conclude the formula, where the formula is dp of I is equal to maximum of A of I plus dp of I minus 2 or dp of I minus 1. And the base case is dp of 0 is equal to dp of 0, dp of 1 is equal to maximum of dp of 1, comma dp of 0. I hope you understood the base case and the formula of this dynamic programming problem. Now let's move on to the code. In this problem, the code is pretty simple. Here, we are given a function named Rob. The input parameter of this function is a vector. Now at first, we have to calculate the size of this input vector. And if the size is 1, then we have to simply return only the single element. If the size is 2, then we have to only return the maximum of first and second element, which is the base case. After that, we have to take a DP array. And for the first element of this DP array, we have to insert a of 0, which is the first element of the given parameter or the given vector. And for the second element of this DP array, we have to insert the maximum of first element and second element of this input array, which is maximum of a of 0 and a of 1. These two are the base case of this DP array. After that, we have to run a for loop from 2 to n, from where dp of I is equal to maximum of dp of I minus 1 and dp of I minus 2 plus a of I. After that, finally, we have to return the last element of this dynamic programming vector. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. The time complexity of this program is big O of n because we have to iterate the entire given array at least 1 times. So here in the worst case, the time complexity is big O of 1. And the space complexity of this problem is also big O of n, where because we have to take one extra vector or one extra dynamic programming array. So in the worst case, the size of this new vector will equal to the size of the input array. So here, the space complexity of this problem is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.